Good day to each and everyone. Today we will be solving another past board exam problem from the Civil Engineer Licensure Examination. So this is under Hydraulics and Principles of Geotechnical Engineering, particularly in geotechnical engineering under the topic stresses in soil involving Mohr circle. So the problem states that the result of a triaxial test on a cohesive soil is as follows. The angle of shearing resistance is 29 degrees. The cohesion is 31 kPa. The maximum shearing stress is 65 kPa. Now we need to find the cell pressure at failure, the maximum principal stress at failure, and the value of normal stress at the plane of maximum shear. Now before we proceed to our solution, we first need to illustrate the problem. So as stated, this is a cohesive soil. So we will draw a Mohr circle diagram with cohesion. Okay. So just draw a Mohr circle. So it's not perfect, but I think it's okay na. So here we have our cohesion. So the angle of shearing resistance is 29 degrees. This is our angle of shearing resistance. Next, we have the cohesion 31 kPa. This is our cohesion. This one. Next, we have the maximum shearing stress. Now take note that this Mohr circle is plotted on an XY plane. The x-axis corresponds to the normal stress, and the y-axis corresponds to the shearing stress. Now from our Mohr circle, the highest shearing stress is here, which is, if we reflect it here, that is equal to the radius of our Mohr circle. So that is just equal to the radius of our Mohr circle. Next is, we will just label the parts of the Mohr circle. So we have here the sigma 3. This is called the cell pressure, or the chamber confining pressure, which also sometimes called minimum principal stress. Next, we have the radius of the Mohr circle, and then another radius. Now if we sum it up from here to here, we'll come up with our sigma 1, or the maximum principal stress. Next, for ease of solution, we'll just give a value here and set that one as our x. We will also assign points within the Mohr circle, so that we will have an organized solution. So let's call this one as point A, B, C, D, E, F, and then G. Next one, don't forget the R here, R. And take note that this is, since this is tangent to a circle, this is 90 degrees. And this is also 90 degrees. Now we'll proceed with our solution for part 1. part 1, we were asked to compute for the value of cell pressure at failure in kPa. So that one, that is our sigma 3. Now, from considering a triangle ACE, this one is 90 degrees, and we have R, which is equal to 65 kPa. We have the phi equal to 29 degrees, and this the value of our hypotenuse here is just equal to this one, that one. So that is equal to x plus sigma 3 plus r. Now we can use the basic trigonometry in solving for our x, for our sigma 3 I mean. So sine phi is equal to r over x plus sigma 3 plus r. But take note that in this equation we still have two unknowns, x and sigma 3. So we will just solve first for our x. So consider triangle ABG. So this is a 90-degree triangle. So this is C is equal to 31 kPa. This is our x, and this is phi equal to 29 degrees. Now, again, by basic trigonometry, we can say that tan phi is equal to 31 over x. So our x therefore is 31 over tan phi, or tan 29 degrees. Tip for this subject is to actually take all of the numbers, do not round off, because it will really it sometimes will not give you the exact answer. Okay, so do not round off, just take all of the answers. So x is equal to 31 over tan 29. So substitute it here for our sine 29 degree is equal to 65 over x, which is 31 over tan 29, plus sigma 3, which is our unknown, plus r, which is 65. So we can use shift solve. So that is sine 29. So again, that is sine 29 is equal to 65 over x, which is 31 over tan 29, plus sigma 3 plus 65, in which we can get our sigma 3 as 13.147 kPa, or say, rounding it off, 13.15 kPa. Just round off in the final answer. Okay, so that is letter B from our choices. Okay, next, for number 2, compute for the value of maximum principal stress at failure. So again, that is just the sigma 1. So for part 2, So sigma 1 is equal to sigma 3 plus r, or sigma 3 plus 2r. 13.147 plus 2 times the r, which is 65. Sigma 1 therefore is 143.15 kilo Pascal, which is letter D. Next, for part number 3, the value of normal stress at the plane of maximum shear, that is this one, from here up to the failure plane, or sigma n. Now from our illustration, that is sigma n is equal to sigma 3 plus r. So sigma n is equal to 13.147 plus 65, or that is equal to sigma n is equal to 78.15 kPa, which is equal to letter B. So that's it. You can screenshot the answer, and okay.